This is section 1.7, transformations in the plane. There is a note sheet and there is another sheet that goes with this. This is like your cheat sheet that you will need to study for the test. So this has all of the types of transformations on it. And you will need, I'll make reference to this halfway through the lesson. So, transformations in the plane. Confusing thing about transforming things. You have a figure over here, and then you're sliding it, you're moving it, you're rotating it, you're reflecting it, you're doing something to it, but the starting image is called the pre-image. The ending figure is called the image. Okay, so they will use that terminology. They'll say, what are the coordinates of the image if the pre-image is this? The pre-image is where you start, the image is where you end. That is it. Okay, now there are three different transformations that we are doing. The first one is a reflection. So you're taking something on one side and you're reflecting it to the other side. You could also be taking a figure here and reflecting it down here. Your line could be a vertical or a horizontal line that you're reflecting across. Okay, it could either be vertical or horizontal, doesn't matter. Okay, the next one, you can't see this very well, so I'm going to rewrite it, is a translation. Translation, you're just sliding things. So you're taking this figure and you're just sliding it across. Sliding it down, sliding it over, moving it up, whatever. Okay? And the last one is a rotation. So you're taking something and you're rotating it around. You can do that either clockwise or counterclockwise. Clockwise is to the right, and counterclockwise is to the left. And we'll talk about the differences between both of them. Okay, so clockwise versus counterclockwise. That's three different transformations that we can have. There is one more that is not on this list. What else can we do to a figure that is not already on this list? What? That's like a kind of like a reflection. Not really. That's what I want. Enlarge or reduce. It's called a dilation. You either make it bigger or smaller. If you think about it, like your eyes dilating, okay? Your eyes dilate when the lights go out, right? If you shut the lights off, your eyes get bigger, and then they get smaller when the light is on. So I'm going to put dilation over here. Dilation is the fourth type of transformation. They leave it out of this section, and they leave it out on purpose because these three over here are congruence transformations. In each one of these three, your figure remains congruent. Figure remains, NS, remains. Two different things tell me that a figure is congruent. Okay, what are the two qualities that congruent have? Equal what? Okay? Shape and size. So same shape and same size. So in each one of these, whether I'm reflecting it, sliding it, or rotating it, that figure that I have stays exactly the same shape and exactly the same size. Does it stay the same shape and same size for a dilation? No. It stays the same shape but different size. Now, what is that called? Shape, E on the end. What is that called when it's the same shape but different size? It's not congruent anymore. What's it called if it's not congruent? Same shape but different size. Have we talked about the word similar before? Like the figures are similar to each other, which means they're the same shape, but they're not the same size, right? Same shape, different size is similar, okay? So that's the reason why they leave off dilation, is because those are for similar figures. We're only talking about congruent figures. We will talk about dilations later on, but not in this section, okay? I think it's like in chapter 3, maybe we talk about it, right? So let's go down here, and I want you to do A, B, and C really quick. Tell which one each one of those is, a reflection, a rotation, or a translation. Go. I'll give you a head start. Okay, what's the first one? A. What are you doing?
Rotation.
Rotation. Okay, now I'm going to talk about rotation because this is all too easy. Rotation. That's too easy just to write rotation, although on your homework assignment you can just give me rotation. But which way am I rotating this thing?
Counterclockwise.
What? Counterclockwise, it looks like, right? It looks like counterclockwise. Could I rotate it this direction, though, too, and get the same figure? Yeah, so it doesn't matter, right? Rotating this figure around that way, I think that's a little bit more than 90 degrees. Let's say that it's 100 degrees, whatever, okay? 100 degrees rotation that way. What would be the equivalent number of degrees that I would have to rotate the other direction in order to get to the exact same spot? 260, right? Because the full 360 is all the way around. Do you see that? So rotating something 100 degrees is the same thing as rotating it the other direction 260 degrees. Yeah, okay? You don't have to say that. I just did just for your information because it's going to be helpful later on. What's this one? B. Reflection. And it's a reflection. You don't have to put this across the what? Y-axis. Reflection across the y-axis. Okay? You don't have to put across the y-axis. You just have to put reflection. But that'll be helpful later on. And then what is C? Is a translation. We just translated it, okay? Now, what way did we translate it? Up, down, left, right? Down and to the right. That is not right. According to the arrow, you see this little arrow, this means that this is the pre-image, and this is the image. Okay, that's the important part. Pre-image and image. So we're starting down here, and we're going up and to the left. Up and to the left. Okay, how many are we going up?
4.
3.
Oh,
3. How many are we going left?
2.
3. We're going up 3 and left 3. All right. When we start to do coordinates on the back side of this sheet, they will do this to you. They will say, and they'll write it in like triangular brackets, and they'll write it like this. So this translation, if we're going up 3 units, is that affecting the x coordinate or the y coordinate? Y, right? Y goes up and down. So up 3 means you have 3 up in the y spot, okay? And if I'm going to the left 3, that's going to affect the other one, right? The x coordinate. What do I put in the x spot right here? -3, because you're going left, you're subtracting 3. So this is the translation vector, they call it. Translation vector. This is talking about how you slide your image. We're going 3 up and 3 to the left. Okay, that's what he looks like. All right, now this next story problem, it's not really a story problem, it's just like asking you something. Example 2. This is a skip it. Okay, have you guys ever played with the skip it before? Yes, okay. The game below shown below involves a weight attached to a bar, attached by a bar to a ring that you can place around your ankle. As the bar passes in front of you, you skip over it, right? It's like a little plastic thing, and it kind of has like, it's almost like a step counter on the end of it, and then it counts how many times you go around. Yeah. It counts how many times you go around, and then you try to beat your friends and see. It's kind of like who can jump the most rope. It's like who can skip the most around without like stopping. Okay. So it counts it, and then you can zero it back out again like a step counter or whatever. And it does that. Okay. Identify the type of congruence transformation as a reflection, translation, rotation. What's it doing? Rotation. Now, I'm going to address one more thing. In a rotation, it's very important to note the center of rotation. Okay? The center of rotation in the story problem is what? Your ankle. Your ankle is the center of rotation here. How do I spell ankle? I don't know. My brain's not thinking. A-N-K-L-E. I don't know why I can't think of that. Ankle. Okay, now, it is important to note that because, let's go over here. You don't necessarily have to write this down, but I'm going to. Okay, let's say I have the point 0, 0, and I have the point 2, 2. And this point 2, 2, I am going to rotate around the point 0, 0, right? If I rotate him, he's going to be over here, and he's going to be the point -2, 2. Okay, if I rotate him like 90 degrees, he's going to be there. Okay, but let's say instead my center is not at the point 0, 0. It's over here at the point 4, 4. If I rotate that over here and the center of rotation is 4, 4, you know where it's going to be at? 6, 2. Okay, so I end up in a very, very, very different spot if I rotate around a different point, right? So the center of rotation is very important. If I rotate it around 0, 0 versus rotating around 4, 4, it's going to be an altogether different point. Make sense? Yeah? Okay. Are you writing? Okay. All right. I'll give you just a second.
Ow. Oh.
Here, I'll give you this. That's the one from this one. Okay. All right, on the back side here, I'm going to show you how to do this the first time, the long ways, and then I'm going to show you how to cheat. All right, so example 3, consider triangle ABC that has vertices of 3, 2, 2, negative 2, and 4, 5. I'm going to zoom this in just a little bit because let's say that each one is like 2 spaces. So if I go over to 3 and up to 2, I'm going to put my dot there, okay? I'm going to space this out a little bit. 3, 2 is there. 2, negative 2 would be like there, and 4, negative 5 would be like there. I'm just going to space this out. So each like 2 spaces is actually 1. Okay. You can do it 1 space. I don't care if you want to do that, but like my writing gets really condensed if you don't. Okay. So this is point A, point B, and point C. A, B, C. A, B, C. Okay? I'm going to write A, B, C over here and the coordinates next to them. Okay? All right, we are wanting to take this image and reflect it across the x-axis. Okay, the x is the one that goes left and right, just in case you didn't know that. That's the x. Okay, so we're basically like taking this guy here and we're flipping it like this. We're taking it, flipping it. Okay, so A right now is like 2 units above the x-axis. Okay, so if we reflect it across the x-axis, he's going to be the same spot 2 units below. That's my new A. Now, do you know how we mark the new A so we know that's the new A and not the old A? You put a little tick mark next to it. Yep. And that is called A prime. It's like a little apostrophe next to the A. That's A prime. So that's how we know that he is the new one. Okay, B was 2 units below the x-axis, so now he's 2 units above. So B is here, and we call that B prime. Again, it's supposed to be 2 units, but I'm actually making it 4 units, so it's zoomed out. Otherwise, our little figure is kind of condensed in there, whatever. And C is 5 units below, so I'm going to make it 5 units above. And now here's where C prime is. So I connect my lines, and that's what he looks like. Okay, he has been reflected across the y-axis, and you can kind of see that. Okay. So let's see what this did to the coordinates. Okay, we're going to do this the longhand, and then B we're not even going to graph. Okay, A was at 3, 2. A was here, and then he moved to down there. So what happened, or what are the new coordinates of A? What are the new coordinates of A? 3, negative 2. Yeah. And then B was at 2, negative 2. So he was down here, and then we moved him up here. What happened to him? 2, positive 2. And this one was at 4, negative 5, and now he is at 4, positive 5. So reflecting it across the x-axis did what to the coordinates? It made the y-coordinate negative. If you're flipping across the x-axis, the y-coordinate becomes negative. Here's the rule for that. xy, when you're doing this, becomes x, negative y. You just take the same coordinates and you make the y-coordinate negative now instead. Flipping across the x-axis makes your y-coordinate negative. It does the opposite. Okay, the opposite coordinate, right? Now over here, we're wanting to reflect across the y-axis, okay? So I'm just going to take a point. We're going to eventually do this to these coordinates, but let's take the point like 2, 3 or something right here. 2, 3. If I reflect him across the y-axis, that's going to bump him over here, and what's the coordinates of that one going to be? If I bump just 2, 3 over here, what will he become? Negative 2, 3, yep. Okay, so what happened when you flipped him across the y-axis? The x becomes negative. So that rule is x comma y becomes negative xy. Yep, that's that rule. So whichever one you're doing, the x or y axis, the opposite coordinate becomes negative. So let's do this. A is at 3, 2. We have these same coordinates as what we had before. A is at 3, 2. B is at 2, negative 2. And C is at 4, negative 5. I'm not even going to graph this because we can figure this out without graphing. This is how you cheat. Okay, so what's my new A coordinate going to be at? What's A prime located at? Negative 3, 2. B is at negative 2, negative 2. And C is at negative 4, negative 5. Perfect. Okay? Good, makes sense. The opposite one becomes negative. Opposite. Okay? Now, they talk about a translation, and this is just like sliding it. Sliding a figure, okay? And you are sliding it along that translation vector, like I said before, which is written in component form, like this, okay? Whatever the x value is, that tells you left or right. Whatever the y value is, that tells you up or down. So here we have these coordinates, Q, R, S, T, okay? I'm going to plot Q, R, S, T, and I'm not going to go by 2's this time. Negative 8, negative 2, negative 9, negative 5. Oh boy, I'm very bad at this. Negative 4, negative 7, and negative 4, negative 2. It looks like this. And I'm going to write them out over here. Q, R, S, T. I am going to graph this one just so you can see what he looks like. I am going to draw this one out so you can see what he looks like when we're done. Okay. The translation vector, if you read from up at the top, is 7, 1. What does that mean, 7, 1? 7 to the right, because 7 is positive, and 1 to the up direction. Okay? Because they're positive, right and up is what those are. If it was negative 7, it would be to the left. And if it's negative 1, it would be down. Okay? So, just think about what these look like. Negative 8 is this coordinate over here. And I want to go 7 to the right. If I take negative 8 and I go 7 to the right, where will he be at now? He'll be at negative 1, right? You're basically like adding 7 to this coordinate, okay? If he's at negative 2 and I go 1 up, where will he be at now? Negative 1. So negative 1 is where he will be at now. I'm going to plot that dot, okay? So you're adding 7 to the x-coordinate and adding 1 to the y-coordinate. Okay, down negative 9, negative 5. Add 7 to negative 9, so negative 2 and negative 4. So negative 2, negative 4 is this dot right there. We're going to see if he looks exactly the same as what he did before. Negative 4 plus 7. Positive 3, negative 7 plus 1. Negative 6. 3, negative 6. Right there. And then the last one, negative 4 plus 7 again, is 3, negative 2 plus 1. Negative 1. So 3, negative 1. And this is what he looks like. Does he look the same as he did before? Yes. So that's why this guy is congruent. We have just translated him. He has remained the same shape and same size. Okay. Now, I can do this without having to graph because I just follow the rules. You add and subtract if there's a negative, right? You just take that vector and move it, okay? All right, the last one. Before we go to the last one, I'm going to have you look at this sheet because this just summarizes what we just talked about all in one place, okay? So when you're reflecting across the x-axis, your coordinates, the y coordinate becomes negative. Okay? Across the x-axis, the y coordinate becomes negative. We wrote that rule on your paper, okay? When you're reflecting across the y-axis, the x coordinate becomes negative. Again, I had you write that rule on your paper, but this is just summarizing all of those at one shot. Okay. We did not talk about this last one, but it's reflecting across the line y equals x, which is this one here. And if you're taking a point and you're reflecting it up over here or vice versa, what do you do with your coordinates? You flip the x and the y. So if it was x and y before, you're flipping them around. Like if you had 2, 3, and I flipped them across that line, it would now be 3, 2. That's what my coordinate would become. I'm just taking them and flipping them, not making any of them negative, just taking them and flipping them, okay? Now, translating was the one that we just did. If you have an xy coordinate like -2, 3, and they're saying move it 7, 4, that means 7 to the right and 4 up since they're both positive. So adding 7 to -2 is 5, adding 4 to 3 is 7. So my new points are 5, 7. This you're just adding when you're translating, okay? Now the last one is what you really need this sheet for, okay? I can remember these two, and I can remember this one, but the rotations are the weird ones. If I'm taking a point like 5, 2, and I'm rotating at 90 degrees, so it's like making a 90-degree angle with the origin, okay? It's going to be up over here, like where it was before, 5 units to the right and 2 units up. Now it's going to be, if I rotate my paper, 90 degrees. This is still 5 units to the right and 2 units up, okay? So that's what it looks like after a 90-degree rotation. But what does it do if I'm rotating 90 degrees? What does it do to my coordinates? What does this rule right here say? XY becomes what? Negative y and then x. So what have I done to my coordinates? Yep, so make y negative. If it's already negative, you make it positive. And then switch x and y. You make the y coordinate negative, and then you flip the x and y. Okay? Now that is a 90-degree rotation counterclockwise. Counterclockwise. Okay? We'll talk about that here in just a second. You make the y coordinate negative, and then you switch x and y. A 180-degree rotation is like taking this point and moving it 180 degrees. They designate it as counterclockwise because if they don't designate it, you assume it's counterclockwise. But 180 degrees counterclockwise is the same as 180 degrees clockwise, right? So they don't have to tell us counterclockwise versus clockwise for 180 degrees. It doesn't matter, okay? What do I do? What's the rule for 180-degree rotation? Yep, we don't flip anything, but both coordinates become negative. Negative. Or if they're already negative, they become positive. They just flip the sign, okay? The last one is a 270-degree rotation, which is counterclockwise. So this way, this point's going to become down here, all right? And the rule there is what? Make the x, I like this rule, make the x negative, then switch x and y. Kind of similar to 90 degrees. Then switch x and y, okay? Now, what happens if they ask you 90 degrees clockwise instead of 90 degrees counterclockwise? What do you do then? Wouldn't have a rule for that. 90 degrees clockwise versus 90 degrees counterclockwise. No. 90 degrees clockwise is going to be the same thing as 270 degrees counterclockwise. Does that make sense? 90 plus 270 adds up to be 360. So if I do 90 degrees clockwise, it's the same thing as 270 degrees counterclockwise. Make sense? What happens if I say I want to go 270 degrees clockwise? Yeah, you're going to go 90 degrees counterclockwise. So this is 270 clockwise, right? And what if I do 180 counterclockwise or clockwise? It just stays the same as that one, right? Because 180 clockwise and counterclockwise are the same. Okay? All right, so let's do this on here. And I'm not going to graph. I'm just going to do these points, and they want a rotation of 180 degrees about the origin. Okay? So F, G, H, J, 2, 1, 7, 1, 6, negative 3, and 1, negative 3. You can graph these if you want to. If you want to see what 180 degree rotation looks like, that's fine. Okay? What's the rule for 180 rotation, though? Both become negative. So xy just becomes negative x, negative y. That's all. Negative x, negative y. So I have the point 2, 1. What will he become after 180? Negative 2, negative 1. This guy will become negative 7, negative 1. What about 6, negative 3? Negative 6, positive 3. That negative 3 will become positive then. And negative 1, positive 3. Does that make sense? Okay. You can graph those if you want to. I'm not going to because that's it. Good? Yeah? All right. Oh my gosh.
Can't even use the chat board.